Alright, we're looking at problem 11-12, an unusual graph. Lauren was flipping through her sister's algebra book when she noticed an unusual graph. She copied it into her notebook to show her study team. The graph she drew is shown below. Lauren wondered what the equation for such an unusual graph could be. It's not a parabola, but it's not a straight line either. It doesn't look like a compound interest graph. What do you think? Lauren asked her team. Clearly, there is lots of patterns. Investigate this graph. Make an XY table if you need to. See if you can figure out what the rule is. Pause the graph and take about 1 to 3 minutes to see if you can figure out the rule. Think about these discussion questions. How does the graph grow? How is the new graph similar to a parabola or a line? How is it different? What would a table of values tell us? One of Lauren's friends, Lars, focused on the graph to see what he could learn. He said, "This graph is kind of like a line, and kind of like a parabola," he said. What do you think he meant? What does the graph have in common with a line and with a parabola? How is it different? Be specific. In your XY table, what patterns do you see? So take a few minutes and go ahead and answer those questions and see what patterns you see and see if you can come up with the equation. In problem 11-16, it says, Lauren went back to her sister to ask what she knew about the graph. She learned that the V shape showed that this was an absolute value graph. The equation for it was y equals the absolute value of x. From the patterns I found, I know that this seems to take any input and turn it into a positive output, Lauren said. Her sister explained that when you find the absolute value of a number, you actually find the distance between that number and 0 on a number line. She used the example, if x equals -7, then the distance between -7 and 0 on a number line is 7 units. So the absolute value of -7 equals 7. Here's another example. We have the absolute value of -3. So the absolute value of -3 equals 3, because on a number line, or in real life, -3 is 1, 2, 3 units from 0. And we do distance in positive amounts, so distance is always shown as a positive value. Therefore, the absolute value of -3 is going to be 3. If we have another example, and we have the absolute value of -8, it's going to be +8, because -8 is 8 units from 0. If we have the absolute value of 20, it's going to equal 20, because 20 is 20 units from 0. The value is always going to be positive because we're talking about a distance. The number is from 0. So now we're going to take a look at the graph again. Alright, so here's the graph that you're going to put at the bottom of your toolkit underneath the cubic graph that you just made. And we have two different equations. The first one on the left is this y equals the absolute value of x. And that is the exact one that we just looked at in problem 11-12. If we put in -5, we get the output of 5. We put in +5, we get the output of +5. So we get this exact V-shaped graph in the positive direction. It falls in quadrants 1 and quadrants 2. And then, to the right, I have a different chart. And this chart, it's hard to read the equation, is for the equation y equals the negative, it's hard to read. Let's see if I can fix it here. We have the negative absolute value of x y equals the negative absolute value of x. So what happens is you put negative 5 in, so you get this. The negative absolute value of 5. So the negative absolute value of negative 5 is 5, but the negative on the outside stays, so the value is then negative. So therefore, all of our negative inputs for x are going to have a negative output, and all of our positive inputs for x are also going to have a negative output, which makes this upside down V-shaped absolute value graph that falls in quadrants 3 and quadrants 4. So now let's talk about the properties of this graph, or both of these graphs. It is nonlinear because it does not make one solid straight line. It is non-proportional because it's not adding the same amount each time. So our table, if we look at it here, starts out by adding 1 each time, right? But it does not make a straight line, so that's why it's not proportional. And it is not exponential because the equation doesn't have an exponent in it, and it's the special graph called an absolute value graph. Alright, so I put the rate of change in the table so you could see it a little bit better. So you could see that you're adding 1 until you get to 0, and then at the 0 you have this turning point where then you start subtracting 1. So the rate of change is not the same. So it's non-proportional because 1, it doesn't make a straight line, and 2, because it's not have the same rate of change the whole way through all your y values. Well, that is it for all of the graphs today. For your assessment on your Type 3 writing, you can expect to see the equations, and you'll be asked to describe how each of the graphs look, what quadrants they fall in, and what their properties are. And by properties I mean, are they nonlinear, non-proportional, are they exponential, are they symmetrical? So this one would be symmetrical, so you could add that to this graph. So you could say that this one is also symmetrical. That's it.